Hello, my name is Rylan Fowers, and I am going to teach you about capacitors in series and parallel in this video. So first, let's talk about what a capacitor is. A capacitor is a device, well, our book defines a capacitor as a device used to store charge. And specifically, a capacitor can hold an amount of charge for every volt that is applied to the capacitor. And so it's capacitance equals charge per volt. There are two ways that you can arrange capacitors in a circuit. You can have them in parallel and you can have them in series. When you hook up capacitors in series, they look like this, with your battery here or your voltage source, and then each capacitor one after another in the circuit, so that the positive side of one capacitor is hooked to the battery, and then the negative side is hooked to the positive side of another capacitor. When you have capacitors in parallel, each capacitor is arranged side by side, so that the positive terminal of the battery is attached to each capacitor, and the negative terminal is attached to each capacitor as well. And when you have them arranged like this in parallel, the voltage across each capacitor is going to be equal to the voltage that is applied by your battery or your voltage source. Whereas when you have capacitors in series, the voltage across each capacitor, it may not be the same, but the charge across each capacitor is the same. And so when you have capacitors in series, the charge will stay constant. When you have capacitors in parallel, the voltage for each capacitor will be constant. And so the equation to find the total capacitance of this system will be 1 over each capacitance. So if we have capacitance 1, 2, and 3, 1 over capacitance 1, 2, and 3, and then you take the inverse of those added together, and that will give you the total capacitance. And to find the total capacitance of this system, you just add capacitance 1, 2, and 3 together. And so the capacitance of this system is going to be much greater than this system, because your capacitance of this system is always going to be less than the smallest capacitor. So if this capacitor was 1 farad, and this one was 2 and this was 3, your total capacitance would be less than 1 farad. Whereas here you would just add 1, 2, and 3 together. And so for a quick review, we have capacitors that store charge, specifically an amount of charge per voltage. You can arrange them in series and parallel. Series, one after another, parallel side by side. And in series, charge is constant, in parallel, voltage is constant. And we will now go over a practice problem so that we can know how to find the total capacitance of a system when you have series and parallel mixed together. And I'll show you how to figure that out. So now we are going to go to our practice problem. And this is a practice problem that I took from the homework. And looking at this circuit here, we have capacitors in series and in parallel, kind of all mixed together. And so to make it a little easier, I'm going to number them. I'm going to call this capacitor 1, 2, 3, 4, 5, and 6. And then just as a reminder, before we start on the problem, I'm going to write our equations up here for our capacitance. 1 over C1 plus 1 over C2 plus 1 over C3, all to the inverse. And this is for capacitors that are in series. And then for capacitors that would be found in parallel, then we would have C equivalence equals C1 plus C2 plus C3. Okay, so if we look here at this circuit that we have, we can realize that the only two that we have, we can try and simple it down, and we can notice that capacitors 5 and 6 are in parallel to each other. And so to find the capacitance of 5 and 6, then we just do capacitance 5 plus capacitance 6. And that would be 0.75 plus 15 farads. So we've got a total capacitance, or equivalent capacitance, for these two capacitors which would be 15.75 farads. And we can take that number and simplify our circuit down to look like this. So that now we can take that number that we just found and plug it in for this capacitor that is the capacitance of 5 and 6. And so we've got 15.75 farads for that capacitor. And now we have a situation where we have three systems in parallel, but in those systems we have two capacitors in each of them that are each in series with each other. So if we look back up here, we can use our equation for series, and we can say, we'll do a capacitor 1 and 2 first. So capacitance of 1 and 2 equals the 1 over capacitance 1 plus 1 over capacitance 2 to the negative 1. So we have 1 over 1.5 plus 1 over 3.5 to the negative 1. And that total capacitance is going to equal 2.0588. And then we can do the same thing for capacitance. This was capacitor 4. And this is 5 and 6. So we can say that capacitance equals 1 over 1.5, plugging in capacitance for capacitor 4, plus 1 over 15.75, which is the equivalent capacitance that we found for 5 and 6, that we simplified into this simpler circuit here. And so when we multiply and do all the math on those, then we get a total capacitance of 1.3696 farads. And this one should be farads also. So now we can take these numbers that we found for our capacitors that were in series to each other, and we can plug them in down here in an even further simplified version of our circuit. So we can say this capacitor here, which would be 1 and 2, has a capacitance of 2.0588 farads, and this one here would have a capacitance of 1.3696 farads. And then this circuit becomes very easy to solve for the total capacitance because it's just 3 capacitors that are in parallel to each other. And we can use capacitance equals C1 plus C2 plus C3. Reminding ourselves that this C1 came from capacitors 1 and 2, and this C2 has been the same the whole time, and then C3 came from these two here, which came from these 3 here. Okay. So, coming back down here, we can do 2.0588 plus 8.54 plus 1.3696 farads, and this is all going to add up to equal 11.082 farads. So this number here is the equivalence of all 6 of our capacitors from the original circuit that we had, that we've simplified down in 3 stages to this final circuit. And so that's how you find the total capacitance of a circuit when it has capacitors in series and parallel all kind of mixed together. And then you can use that total capacitance to solve for different variables that are given in the problems that you do on your homework. So yeah, that's the practice problem, and thanks for watching.